Hey everyone, I hope all of you that made it to France are enjoying southern France and the being at the ITER facility. That would have been really, really nice to see. I'm back here in Massachusetts. So I'm a developer at MathWorks. I've been here since 2013. I've been working with the HDF Group off and on for almost as long as I started at MathWorks. So I thank the HDF Group for inviting me to this talk. So what I'll do today is I'll give a recap or overview of the HDF5 capabilities that we have in MATLAB. Then I'll talk about what we added new in 22A, which is our current release. I'm going to give a demo that wraps all of the new features we added all together in one big demo. I'll touch on the community collaboration effort that we're doing and from new communities that we're working with, and talk about our highest priority future work. So just an overview. Oh, no, I thought there was a question. Sorry, I think there's some feedback. So overview of scientific data in MATLAB. We support not only the Sci formats, I call them Sci, but the image formats. That's our team. So for the scientific data formats, the big ones are HDF5, HDF4, NetCDF. We support a few others. And for image file formats, the big ones are TIFF, especially in the biomedical community, and JPEG 2000, as well as JPEG and PNG and all the others. Our friends in the mapping toolbox support Esri shapefiles, the vector formats, raster formats, GeoTIFF, and WebMap service. So we work with them quite a lot on the earth science work that we do. So a quick overview of the functionality in MATLAB for HDF5. We have two HDF5 interfaces. Our high level provides ease of use, but it doesn't have as fine-grained control as our low level. So for those of you who've used MATLAB, you'll know H5 read, H5 create, H5 write. That's our high-level interface. And then our low-level interface wraps the HDF5C API with tons of functionality. And that's the equivalent of H5D open to open a data set, H5F open to open a file. And if you see in our doc, you'll see the high-level functions that we have. We have 7 of those. And we have 330 and counting low-level functions. We just added a bunch that I'll talk about for SWMR. And those are pretty much thin wrappers to the HDF5C API. So what have we been up to? So as a recap for 20B, we added cloud support to all of our HDF5 interface. So that is read and write for both Amazon S3 and Microsoft Azure. And Hadoop, we added read-only support. There was a limitation with writing on Hadoop. And again, enabled all throughout both our high and low level interfaces. For 21A, we worked with our friends in the MatFile team at MathWorks. So MatFile, if you've used MatFiles, MatFile version 7.3 are based directly on HDF5. And we consulted with them so that they could make the MatFile 7.3 cloud enabled. And in 21B, we did a major upgrade to HDF5 1.10.7, which was long overdue. That was moving up from 1.8.12. We also added support for SWMR and virtual data sets. And new in 22A, we did the upgrade to 1.10.8, and we added the capability to write data sets using dynamically loaded filters. We've had read support for reading data sets compressed with dynamically loaded filters since 15A. So this is long overdue, and finally we got it in here. And a couple more refreshers about the cloud. How did we make this work? Sometimes I get asked that. Is we wrote our own in-house HDF5 virtual file driver that borrowed concepts from the HDF5 Sec2 driver. And we coupled that with an in-house cloud provider architecture that is a foundational framework here at MathWorks that has the access to the cloud locations. And with callbacks to the HDF5 library, we were able to support, that's how we were able to support both read write on S3 and Azure and read only on Hadoop. So not only is it support throughout our high and low level interfaces, but it's also including the new features that we added, the SWMR VDS and the filter plugin stuff. And there's just some sample high level code. This is H5 creating a data set on S3. With chunking and compression, H5 writing the data, data set to Azure and reading from Hadoop. So that was really exciting that we added that, and we're getting a lot more questions, especially from the earth science community, about being able to access HDF5 and NetCDF4 data on the cloud. And a quick refresher about what we did for SWMR and VDS. So again, not just SWMR and VDS, but we also added some functions for fine-tuning the metadata cache and partial edge chunk feature. We also added a brand new, actually 2 doc topic pages, one specifically for SWMR and one specifically for VDS, which has really nice examples of tying these all up together. Okay, so what is new 22A? Finally, we now have full round trip read write for, I call them DLFs because it's a lot to say, dynamically loaded filters. So sometimes I call filter plugins, sometimes it's a DLF. But finally, we have write support. So how did we enable that, and what does it look like to the customers? So from H5 Create, from our high-level interface, we added 2 new name value pairs, custom filter ID, which is the registered filter ID, and custom filter parameters, which is optional filter data, which is equivalent to the CD values in the H5P set filter low-level, C API. So how would you use this? This is just an example with bzip2. So hopefully everyone knows about the registered filters. I think a lot of folks have been using the compression in these talks. So you just make sure that you have the filter ID that's registered with the HDF group, and then pass that in to H5 Create with chunking set for the custom filter ID 307, and then custom filter parameters for the bzip2 compression level. And that's all you need to do from the high-level interface. And then just write the data set as usual. And for those of you who are more C programmers and who like to use our MATLAB low-level interface, we have the long existing function H5P set filter. And what we did here is simply enable this filter ID to be something other than the predefined filters in the HDF5 library like gzip. So low-level code here in our low-level interface, the same example. You set up the data set as usual, set up chunking as usual. The only change here is just H5P, our wrapper set filter, and pass in the filter ID and the filter flags and the filter optional data for the filter, the CD values. And then you can check to see if the filter is available, to double check, and then you just create the data set and write it as usual. And this is an excerpt from our doc, and not just, we don't just have H5P set filter, we have about 7 or 8 of the H5P interface filter related functions and the 2 ones in the H5Z API. And for reading, so again, since 15.8, it just works as long as the filter plugin is installed and HDF5 plugin path is set, and I'll talk about that in a second in the next slide. So how would that look for reading? You can use H5disp as a high-level function to just explore the high-level contents of the file. It will say unrecognized filter, but it does specify that it's, because it's not a predefined one, it will specify that it's the HDF5 bzip2 filter, gives the link. And then this is just reading a hyperslab, just as long as that's set, it will just work seamlessly. So that's really nice too, but that's again been working since 15A. We also added, and this is good because we've had some folks in the community ask us about, some folks who aren't exactly more power users, more the casual users, ask us how to set up the environment to use dynamically loaded filters. So we created this new DLF topic page that talks about the installation and the setup, and has a really nice example of how to use them. Okay, so I'm going to touch on the DLF workflow requirements. I think a lot of you may know these, but just as a recap. So the filter plugin, you need to install it on your system. You can either grab the pre-built binaries, like for instance, the HDF group has bundled up the binaries for the most common plugins for the last few releases. Or you can find the source from the links on the GitHub projects and build from source. And I've built from source. I've done both. I built from source to test our feature on all 3 platforms, Windows, Mac, and Linux. And I've also used the pre-built binaries from the HDF group. So that was very handy. So thank you to them. This is important. Set the HDF5 plugin path environment variable. For Windows, the safest way to do it before starting MATLAB is to set it from the system properties and the environment variables there. I'm not exactly a Windows developer, more of a Linux developer, but I think once you're in MATLAB, I think if you don't do that before starting MATLAB, you'll be okay. But the safest way is to do it while setting the environment variable in Windows. For Linux and Mac, you set it from the terminal, and then just start MATLAB from that terminal. That's the important part because we have some users confused about that. So I use the TC shell. So it's just set env HDF5 plugin path to the location of my binaries for the bzip2 filter. And then once you're in MATLAB, you can use the get env command in MATLAB to just check that the plugin path is set correctly. We have set env as well, but this is for Linux. Just make sure that you set it from the terminal, and Mac too, before starting MATLAB. Then just check it with get env. I'm now going to show a demo that wraps all this together. And those of you who've seen my previous talks last year might recognize this. So what we did is we tweaked it a little and we added the dynamically loaded filter workflow in here. So just to set this up, my colleague at MathWorks who works with our team is a physicist who made this awesome demo. So what he did was he grabbed real bathymetry data and he wrote that out into 8 slabs on S3, using 4 of them which are written with the data set with compression is BLOSK, and the other 4 are written with bzip2 compression. So those sit on S3. Then on Azure, he created and wrote to an HDF5 virtual data set. So he bundled up all those on Azure. They're virtually pointing to the real ones on S3. Then over here, we have SWMR and VDS simulation. We have 3 simulated ocean sensors, and they each have 3 writers. They are SWMR enabled and for different regions, and they're disjoint, and it's modeling a wave formation. And then there's also a VDS, a virtual data set, that each of these files has 2 readers. One is to display the 2D contents in a graph, in a plot, and the other reader is to create the virtual data set. And then when this all comes together, he overlays the wave modeling with the VDS on top of the bathymetry data, which is coming from Azure, and we're going to watch it all work in a minute. So let's see how this goes. Hopefully this will work. Live demo, warning. Okay, so here's the slabs on S3. There's 4 with BLOSK compression, 4 with bzip compression. There's the virtual data set created from those that sits on Azure. And there's the bathymetry data. We're going to rotate it. That's the virtual data set all put together. And then here come our SWMR enabled files that are writing data from the sensor. And we're about to display the information, and there we go. So this the wave model is mapped on top of, overlaid on top of the bathymetry data. And you'll see for the VDS, he made a disjoint. So if you look at the bottom here, you'll see that that's a disjoint section, and he filled that with fill values. So that's why the model on top is, to make it, just to explain, this is the 2D virtual data set, the 3 different files, and the integrated virtual data set on top. And then this section here, this orange, that's the fill values. So that's why that shows the disjoint region. So this shows that we can use the compression and the dynamically loaded filter feature on S3 and Azure. And we did try to do the DLFs with SWMR on this side, and we ran into either a misunderstanding of what we believe the HDF5 library does, or the limitation in HDF5 to do with file space recycling. But anyway, I'll talk to the HDF group about that, and we'll see if we can figure that out, and then we can make an even more awesome demo for that. Okay, so I'll touch on the community collaboration work that we were doing. So we have long existing collaborations, and we're starting up a bunch of new connections. So for the HDF group, again, I really thank them. We have a really strong relationship with them. It's a very long relationship. We have had monthly meetings for the past 2 or so years where we talk about technical details and also share planning information for both their features and our timeframes. And that's been very, very helpful. We've also given them a lot of feedback about security vulnerabilities in the library that we're hearing from our customers throughout MathWorks a lot about, if there's a big customer that we have and they're not willing to upgrade to the next version of MATLAB because we have third-party libraries that we use with CVEs in them, those are security vulnerabilities, then they're hesitant to upgrade. So we've been feeding that information to the HDF group, and they've been fixing the CVEs, which is awesome. And we've also been working with them on performance. We have this one particular workflow about writing many data sets with only scalar or just a couple of elements in them. So they've been working hard to get the performance for that workflow back up to the level that we saw in 1.8.12. So again, a big thanks to them. We are starting new collaboration with Neurodata Without Borders. Now, some of you who are at HUG, I can't remember if it was the spring or the European one or the fall one. Andrew Tritt from Lawrence Berkeley presented on MAT-NWB and Neurodata Without, actually I think it was more in general about Neurodata Without Borders. So they have a MATLAB interface, which I just mentioned, MAT-NWB, and we are collaborating with them. We have a newly formed working group, and what the vision of that is to hear feedback from them about what they're looking for in our features, and to help design and contribute code and features to the MAT-NWB project. So that's really interesting, and they were instrumental in giving us feedback about working with the dynamically loaded filters and setting up the whole environment. So because of that, we took that feedback and we put it into our planning of something that I'll talk about in a second. And finally, we have a long relationship with the Earth and Climate Science communities. I go to the ESIP conference every year. We work closely with the NetCDF folks at Unidata. So what we're doing here is it's not planned yet, it's under consideration, but we want to add a bunch of climate data connectors. There's an example one here that we already have in our file exchange is a connector to the Copernicus Climate Data Store. We want to add a bunch of new ones of those for the most popular climate data providers, and also make contributions to open source community toolboxes like the Climate Data Toolbox, which is one we hear a lot that our customers use. It's linked on our file exchange to the GitHub project, and we'd like to make contributions to that because the person who created that doesn't have a lot of time to maintain that anymore. And then finally, what are we going to do in the future? Our highest priority, I didn't want to talk about it this talk. I talked about it a lot last year, but we're still shipping two HDF5 versions. It's a very long story. Let me know if you want more info offline. But we ship both the 1.8.12 binaries and the 1.10.8 binaries. And we don't want to have to do that. That's all related to that performance issue. So our biggest goal is to ship one version of HDF5. That's a lot of extra overhead for our team to maintain two versions. We also want to really improve the filter plugin experience. We're considering shipping a bundle of the pre-built plugin binaries like HDF Group is doing, like a lot of the folks on the GitHub projects are doing. I think that will help our users a lot. Also make it the experience of setting up the whole environment. Maybe we can have something that will create something in the MATLAB startup script automatically that will set all that up so the user doesn't have to fiddle with that. We've heard some reports from our customers that they would like to see BDS and SWMR control in our high-level interface, so we're considering that. And of course, performance, not just the performance issue that I talked about a minute ago, but also our longstanding in our MATLAB code and our underlying C code. And we know we have areas that we can improve performance there, so that's definitely something that we're doing. We're doing benchmarks right now, and we should have some performance improvements soon. And then we're going to continue community engagement, hope to continue working with THG. They've been great. I know a lot of you are in the higher energy physics community, so please provide us feedback on the dynamic loaded filter feature, SWMR VDS, anything else, any wish list that you want. And for the Earth and Climate, well, actually this is for anyone, but mostly for the Earth and Climate data providers, we're seeing a lot of data hosted on the cloud providers like the NASA, PODAC, JPL, that is NetCDF4 format. And we would love to see pure HDF5 files on there because we have the seamless integration to read and write to the cloud locations. So that would be awesome. And to sum up, MATLAB is current. Well, I can't say that first bullet is true now because I just saw the email late last night that HDF5 has now released 1.10.9, so that's on our to-do list. So MATLAB is almost with 1.10 branch. 22A ships with 110.8. The full round-trip support for DLFs. The comprehensive doc pages that we added that should help a lot of users. hopefully they read the doc, and we're expanding our community involvement, and we're looking for more opportunities. So if you have any feedback, any wish list, anything you want to talk to me about, there's my email address. I love hearing from customers. I love hearing from people in this communities that work with HDF5. So that's it. And I do want to, let me just, current slide. Do want to give my, okay, this isn't going to work. Great. Just my acknowledgements here to the HDF group. Again, I can't thank them enough for helping us. We have questions. We ask them a lot, and they're very responsive to us. So thank you again, and I look forward to questions. Thank you.
Thanks, Ellen. Very impressive demo, and also thanks for perfect timing.
Oh, good. Awesome. I wasn't even watching the clock.
Okay, here's a question.
Oh, hey, Ellen, Alexander from HDF.
Hey, how are you?
I have a question for you. You said, hey, hi, Ellen. I have a question. You mentioned that you can write HDF5 files in the cloud.
Yeah.
That basically means you rewrite already existing object in the cloud, or you actually have some secret way of adding bytes to an already existing object in the cloud object store.
Secret way, top secret.
Because
we actually go at the low level and overwrite and write the bytes. So we adapted our own version.
Overwrite the.
We do it at the very low level. So like your Sec2 driver is working at the very low level, and read at the low level file I/O and writing and reading bytes. We're doing that as well.
So
does that answer that?
Start creating HDF5 file in a cloud object store. Essentially, small parts of my file will go to the object store and be written to the same object.
I'm sorry? Oh, be written to the same object? I think so.
Because as far as my capability, my understanding of cloud object store is that you cannot update something that already, unless you completely rewrite it.
Okay.
In other words, you cannot add to something, you are basically rewriting it.
I'll talk
because
to
that's the whole problem.
Okay, no, I see what you're saying. That part of the infrastructure is mostly handled by the infrastructure I mentioned at MathWorks. That is a library and that does all the cloud provider stuff. So I'll talk to them to figure out how they do that magic. And I'll talk to another developer here about the one who wrote the actual our HDF5 virtual file driver and figure out how that's done. So sorry, I don't know the answer to that, but I'll get back to you.
Okay. Thanks.
Okay. Yep.
Go ahead. Any other questions here?
Anything else?
No? Oh, Dana.
Hi, Ellen. So the VFD that you wrote, did you use any of the read-only S3 VFD code, or did you write it completely from scratch? I don't remember.
From scratch.
Scratch? Okay. Curious.
Thanks. Any other question? Was there a question online?
Yeah, so about the shipping the pre-built DLFs, I think that definitely would make things a lot easier in terms of using those. Because I think we just had a conversation this morning that some people were shying away from using the dynamically loaded filters because of difficulty of distributing them. And in the case of MATLAB, since you're shipping an HDF5 library, often you need to build the filters linked to that, unless you use the trick that H5Pi used, which actually has some other complications. So I think that definitely would be appreciated, especially, but although I think it's a little bit difficult figuring out what is the standard set of DLFs distributed in.
Right, but thank you. That's really great feedback. We've heard that from others, like I mentioned, so I'll definitely take it back to my team and see if I can bump up the priority on that.
And then a question is, how do you handle data types that MATLAB doesn't necessarily recognize? So.
Oh, you mean which data types wouldn't MATLAB recognize?
So I think the one issue I ran into was I actually had 12-bit data that I had encoded as 24-bit integers. And I think I was having some problems with MATLAB trying to load that data. In H5 what they do is they allow me to load that as into 32-bit integers. But I think what was happening in MATLAB was it was trying to load it into, it added another dimension of 3 bytes.
Oh, that
And
should.
it kind of looked okay, but then it didn't quite load correctly either. So
Okay.
yeah.
Yeah, if you send me your workflow, again, my email is in the presentation. It's easy, lnj@mathworks.com. Send me your workflow and I'll figure out what's going on there. But we have a one-to-one mapping between the HDF5 library and our data types in MATLAB.
Right. I think the trick is that with HDF5, it's also possible to find new types, and
Yes.
obviously you can't anticipate all of that. So, but yeah, I'll reach out to your support channels and
Awesome.
get in
Thank
touch.
you so much. Thanks, everyone.
All right. Thanks again, Alan. Great talk.
Thank you.